Jai Hind everyone. My name is Amrita Bhatnagar. Today I am going to explain a very important algorithm from the COA subject. The name of the algorithm is restoring division algorithm. So these are the main outlines of the lecture: binary subtraction, binary division, hardware implementation, division flowchart, and in the last we will discuss an example of the division algorithm. So firstly we should understand what is the meaning of binary subtraction. So you can see here in the binary subtraction, when we subtract the 0 from the 0, the result will be again 0. So you can see here, when we subtract 1 from the 0, then we will get 1. 1 minus 1 is equal to 0. And the last, when we subtract 1 from the 0, then we will have answer or result 1, and because we have a 1 borrow also here. So this is the binary subtraction, example of binary subtraction. Now we will see the example of binary division. So you can see here we have two numbers. First number is dividend, which is divided by the divisor. So you can see here, this is the division in the binary form. So firstly you can see here we have, this is the quotient. Firstly we will divide the number with 1. So we can write here 1 0, which is a divisor. Now minus this divisor from the 1 1, and I will get the number 1. And then because of this 1 is less than 1 0, so that we will take another number 1 1 from the dividend. And in this way the whole process will work, and we will get, in the last we will get the quotient, and here we have a remainder. So you can see here we have two main important parts here, dividend and divisor, and in the result of division we will have a quotient and remainder. One more example you will see here. So this is the another example of binary division, where we are going to 101, where we have, this is the dividend and 101 is the divisor. So firstly we will divide it with the 1, and you can see here the 101 will be subtracted from the 101, first 3 digits of the dividend. Then we will get 0. Then we will have here again 0 1 we will have here, and again we will divide it with the 0 0, because we have taken 2 bits here, so that's why we have here 0 and 0, and again we will divide it with the 1. So this is the another example of division. So we should understand that in the division case we have two important numbers. First one is a dividend and another number is a division, and at last we will have a quotient, and remainder also is very important thing. So these are the main important numbers here. Now we will see how the division will be work in our system, how the division algorithm work in our systems. So you can see here, this is another example of binary division. So you can see here this is a quotient, this is a dividend which is stored in the A, and this is the divisor which is stored in the B. Now there is one most important thing in the binary division is the case of overflow. Now the question is how we can find out the case of overflow here. If the size of the quotient is more than the size of the register, then this divide overflow problem will arise. So how we will find out we have an overflow problem in this division? So find out the problem, we have to use this condition. If the value of A, where the dividend is stored, is less than B, in the A the main higher order bits of the dividend are stored, and in the B we have stored divisor. So if the higher order bits of the A is less than divisor, then that means the quotient will have 5 bits. For example, if we have the register of 5 bits, so only 5-bit quotient can be stored in the 5-bit register. So there is a need that the quotient should be 5-bit. If it is more than 5 bits, then there will be problem of division overflow. So in this way we can find out we can compare the value of A and B. If the value of A is less than B, what it means, the question will be of 5 bit. But if there is a condition where we have the value of A greater than or equal to B, then this is a case of division overflow. So we don't proceed in this case. We will stop the division in the case of overflow. Fine. So we have to firstly check the numbers and overflow conditions, so that there should not be any exceptional case arise. Now, hardware implementation in the case of division algorithm. So you can see here we again need 3 registers in the case of division algorithm, like the multiplication algorithms. For example, A and Q registers are used for the dividend. Dividend can be of, for example, if we have 5 bit of register, the capacity of one register is 5 bits, then we will take 2 register to store the dividend. So 10 bits dividend can be stored in the A and Q. So in the starting, the dividend will be stored in the A and Q, and the divisor will be stored in the B register. Fine. Now we need some flip-flop, or you can say 1 bit of registers also to store the sign, because this is a restoring algorithm where we use sign magnitude data, or we are using here sign magnitude representation of the numbers. That's why we need another register or 1 bit flip-flop to storing the sign. So we will not use sign in the registers. We will store these sign bits in the separate flip-flop. Okay, and you can see here there is another register is also required, which is known as a E. E is used for the carry bit. If there is any carry bit in the algorithm, then in the E the carry bit will be stored. So in the QS we will have resultant sign bit. Okay, and in the AS we will have dividend sign bit, and in the BS we will have divisor sign bit. And after the completing of the algorithm, we will have the result or quotient in the Q register, remainder in the A register, and we will have the resultant sign, or you can say quotient sign, in the QS register. Fine. Now there is a need of a sequence counter also there. It will reduce as the algorithm will complete, or steps will be proceed, then the sequence counter will be decreased in the each step. Now another need of the algorithm is complement and parallel adder. Complementer used to add the numbers to minus. When we require to minus the number, then we will use 2's complementer to add by the help of 2's complement addition, and parallel adder is also required in this case. So now we will say here how the this algorithm will work. This is the flow chart, division flow chart, sign magnitude. Again I am telling you, this is the number which is used here in the form of sign magnitude number. That's why it is known as the sign magnitude division flow chart. In the case of sign magnitude, we can use sign and the magnitude value of the positive numbers and negative number both. But in the case of 1's complement representation and 2's complement representation, we use 1's and 2's complement representation. But in the sign magnitude, we will take direct magnitude only. That's why it is known as sign magnitude division flow chart. So firstly, we will see here, we will store the dividend into the AQ. Dividend will be stored in the AQ, then and divisor will be stored in the B. And the sign bits of these two numbers will be stored in the separate flip-flop. For example, you can see here dividends sign bit will be stored in the AS and divisor sign bit will be stored in the BS. And when we XOR these two sign bits, we will have the sign bit of our result. Because the table of the sign XORing is, you can see here, for the different numbers we will have 1, and for the same number we will have 0. So this is the table of the XOR. So when we have plus and plus, the answer will be plus. If we have minus and minus, the answer will be again plus. When we have 0 or 1, you can say 1 plus and 1 minus, then the answer will be minus. So in this way, XOR gate will be work perfectly for the to find out the resultant sign bit. Now next one is the sequence counter. Now if the size of the register is n with the help with adding with the sign bit, then n minus 1 will be the sequence counter value. Okay. Next is the step is a plus b bar plus 1. EA is equal to, E is the AND carry, A is the register which stores the dividend, and B is the register which stores the divisor. So firstly we will use a higher order bit of the A and we will minus the value of B from the A, so that we can find out the overflow case. If we have already told that we have already discussed that if the value of A is less than, then there will be no problem of divide overflow. But if the value of A is greater than or equal to B, then there will be a problem of overflow. So we will check it by the help of minus binary subtraction. So we will subtract A minus B, we will do by the help of 2's complement method of subtraction. So we will take 2's complement of B and we will add this 2's complement of B to the A, and then we will find out the value of A and E. If the value of E is equal to 0, what it means? A is less than B. So there is no problem. We can proceed for the division in this case. So you can see here, again we will add the value of B which we already deduct from the A. With this value we will add it again into the A and we will get the value of EA, and the value of divide overflow flip-flop will be 0 here, because there is no chances of divide overflow condition. So we can proceed for the division. And in another case, when the value of E is equal to 1, what it means? A is greater than or equal to B. And if the value of A is greater than or equal to B, what it means? There is a chances of divide overflow here. So the value of A, if DVF or division overflow will be 1, and again we will add A plus B, but we will stop the division here, and because this is a case of division overflow or divide overflow here. So we should understand that there is a main problem in the system if there is a condition of divide overflow occur. So we'll ignore it, or we will avoid this condition. So we will check this condition firstly. If there is a chances of divide overflow, we will end the process here only. Then another case, when there is a no chance of divide overflow, we will go for the next step, which is the division step. So firstly we will start with the first step of division. First one is the shift left EAQ. We will firstly shift the EAQ into the left. If the value of E is equal to 1, then we will add, minus the value of B from the A. Okay, but the value of E already 1 here. In the next case, if the value of E is equal to 0, again we will minus the value of B from the A. But here E is the value of 0. Then after the subtraction, if there is a value of E is equal to 1, then the Qn will be 1. The value of Qn will be 1. In this case, already the value of E is 1. So after the subtraction also, we will keep the value of Qn 1. In the next case, if the value of after the subtraction, if the next case the value of E is equal to 0, what it means? A is less than B. Then there is no need to keep the value of or change the value of Qn is equal to 1 if the value of A is less than B. Now again we will add A plus B. This is the restoring step. in the division algorithm, because we are discussing here restoring algorithm. So that's why we have to restore the value of A here. So by adding the value of B, because we have already deducted the value of B from the A, but we don't get the value of E is equal to 1. So we again restore the step and A plus B will be done here. So now in the next step, if the value of E is equal to 0 or if the value of E is equal to 1, then again we will go to the next step. In both cases we will go to the next step, that is the decreasing the sequence counter, because we have completed one step here. That's why we need to decrease the sequence counter here. So now the sequence counter -1 will be here. Now again we will check the value of the sequence counter. If it is the value of sequence counter is 0, what it means, now we will end the process here. And when we end the process here, the quotient will be stored in the Q register and remainder will be stored in the A register. If it is not, if the value sequence counter is not equal to 0, then what will happen? We will again go for the loop, for the same process again and again up to sequence counter will be become to 0. So this is the process of sign magnitude division flow chart, or we can say this is the restoring division flow chart. So now we will see, we have already seen that this is the algorithm of or flow chart of the division algorithm. We will see a example of the division algorithm also. We will take two numbers and then we will apply this algorithm on the numbers. You can see here. So this is the division algorithm example. You can see here we have four numbers: A dividend, B divisor, Q quotient and R remainder, which I have already discussed. Dividend will be divided by the divisor and in the result we will get quotient and remainder. So dividend will be stored in the A and Q. Dividend will be stored in the A and Q. So you can see here the value of A is here 0, 1, 1, 0 and 0, 0, 0, 0, 0. Because we can see here we have 5 bits of registers, so that's why the value of the sequence counter will be 5 here. Now you can see here, firstly the first step is in the division algorithm is shift left. We are not considering here the checking of the overflow deduction. We are starting here from the division only. So in the case of dividend, you can see here this is dividend is stored in the A and Q. Now first step is shift left EAQ. When we will apply first left shift, so you can see here this 0 will be come to this E, and we will have the value of 1, 1, 0, 0 in the A and Q 0, 0, because again 1, 0 will be serial input will be 0 here. Fine. After the next step is, after the shifting EAQ, add B bar plus 1. So already we have the value of B is 10001, which is the divisor value, and we have already find out the value of B bar plus 1, which is the 2's complement of B. Now we need to add this 2's complement into the A. So you can see here when we add this B bar plus 1 into the value of A, we will get here the value of E1. Fine. After the adding B bar plus 1, if the value of E is equal to 1, what is the condition? We have to set the value of Qn or Q is equal to 1. So this is the number of Qn. Qn is this bit. So we will keep this or set this value 1, because the value of E is equal to 1. If the value of E is equal to 0, then we will not set this value 1. We will have to keep this value 0 only. Now one step is completed, because I have set this value 1, then the sequence counter will be decreased to 4 here. Now again next step will be started. So we will start with the shift left EAQ. So we have mainly two steps in this algorithm. First one is the shift left EAQ and add B bar plus 1, and after this step we will check the value of E. If the value of E is equal to 1, so we have to set the value of Qn is equal to 1. if it is not equal to 0, what it means, we have to keep the value of Qn is equal to 0. There is no need to change the value of Qn here. So, you can see here in the next step, you can see here shift left EAQ. Shift left EAQ again, when we have shift left EAQ, now we have this 0 here in the E. Now the value of E is equal to 0 and we have here the serial input 0. Add B bar plus 1. Now again I will add B bar plus 1. After the adding, again we have the value of E is equal to 1. So we can keep again the value of Qn is equal to 1. So you can see here again we have this value 1. So again I have completed 2 steps. So that's why the value of the sequence will be decreased to 3 here. Now in the next case, what will happen? Shift left EAQ. Again we will start with this step. And you can see here again this 0 will be come to here and 1 will be discarded. And from this side we will add 0 from the serial input. Now add B bar plus 1. Now we will add B bar plus 1 here only. After the adding this value, now in this case we will see here the value of key is equal to 0. In this case we don't have the value of E is equal to 1. So there is no need to set the value 1. We have the value of Qn is equal to 0. So we will left this value as a 0. Now in this case there is a more extra step is there to add the value B, because we have E is equal to 0. Then we need to add B again. We have to restore. This is known as a restoring the value. That's why this algorithm is known as a restoring division algorithm. So add B here. When we add here B, so again after that we will get 0, 1, 0, 1, 0 and E is equal to 1. But after the restoring step, we will not check the value of E. Here there is no meaning of E is equal to 1. Now again we will start the algorithm again. Sequence counter will be decreases to 2 and we will start shift left EAQ. Again shift after the shifting Q will be here. 1, 0, 1, 0, 0 will be the value of the A and the value of the Q will be 0, 1, 1, 0 and 1, 0 will be input from here. Then add B bar plus 1 here. We will add this value again. Again we have the value of E is equal to 1. So that we will set the value of Qn here. You can see here we have set the value of the Qn is equal to 1. Now again one step is completed. And we will decrease the value of sequence counter. Now the value of sequence counter is 1. Now in the next step again we will start with the shift EAQ. When we start with EAQ, shift is EAQ, so you can see here the 0 will be shifted to here only. And then we add the B bar plus 1. We will get this value here. Now you can see here after the adding the value of B bar plus 1, because you can see here the value of E is equal to 0. So again the value of Qn will be 0 here. We will not set the value of Qn 1. So this is already the value of Qn is 0. So we will left it as it is. Now next step is, because the value of E is equal to 0, we have to add the B also here. Because again this is the restoring step. So we will add the value again. And we will get here in the remainder we will have, in the E we have 1, in the remainder we will have 0, 0, 1, 1, 0 and in the Q register we have 1, 1, 0, 1, 0. So in this case we have quotient is equal to 1, 1, 0, 1, 0 and remainder is 0, 0, 1, 0. So in this way after the and E will be neglected. We will discard the value of E. So in this way we will apply the restoring algorithm into the sign magnitude numbers. Fine. And the sign calculation will be done using the XOR gate. It depends on the what is the value sign bits of the A and B. If both are the positive number, the answer will be positive. If both are the negative number, then again answer will be positive. If both are the different positive or negative, then the answer will be negative here. Fine. So this is the division algorithm. I hope you will understand it very nicely. Thank you.